Hello students, welcome to a series of mathematics program for grade 10 and grade 11. The topic for today is matrices. This is the first part of the chapter Matrices. In today's lesson, you will learn how to display information in the form of a matrix of any order. You will also learn how to solve problems involving a calculation of the sum and difference of two matrices where possible, as well as interpret the results. So let us start. In grade 9, you have learned about the chapter Matrices. You will remember that a matrix is simply an array of numbers, and each number is called an element. You have below some examples of matrices. So for example, this matrix has elements -1, 4, and -5. So these entries are what we call elements. The elements now can be arranged in rows and columns. The horizontal entries are called rows, while the vertical entries are called columns. So look at this example. The horizontal rows, horizontal are rows, vertical we have columns. So here, this is vertical and it is called a column. Here we have horizontal entries and we have a row. So I repeat, row will be horizontally and column will be vertically. Now we have what we call the order of a matrix. What is the order of a matrix? So the number of rows and the number of columns of a matrix is called the order of the matrix. We always state the number of rows first and then the number of columns. So we always write row, then columns. Look at this example. How many rows do we have here? Row 1 and row 2. So we have 2 rows. How many columns? Column 1, column 2. We have 2 columns, 2 rows and 2 columns. So the order of the matrix will be written as number of rows by number of columns. So 2 rows, 2 columns. I will write the order of a matrix as 2 by 2. This example, how many rows do we have? Row 1, second row, and the third row. So we have 3 rows. How many columns? We have only 1 column. So the order of the matrix will be 3 by 1. Next example. Matrices can be classified as follows. We have what we call a row matrix. So as the word, as the term indicates, row matrix will have only 1 row. We have a column matrix which will have only 1 column. So we have only 1 column. And then we have a null or 0 matrix where all the elements will be 0. The 0 matrix or the null matrix can be of any order, but all the elements will be 0. We have a square matrix. So square matrix means you have the same number of rows and the same number of columns. We have exactly the same number of rows and columns. So here you have a 2 by 2 matrix, and here we have a 3 by 3 matrix. So we have 3 rows, 3 columns. Same number of rows, same number of columns. We call it a square matrix. Now, a diagonal matrix is a square matrix with all the elements 0 except for those in the leading diagonal. What is the leading diagonal? So here is the leading diagonal. In the leading diagonal, the elements are not 0, but all the remaining elements will be 0. So I repeat, a diagonal matrix is a square matrix with all the elements being 0 except for those in the leading diagonal. So here for the 3 by 3 matrix, this is the leading diagonal. The elements in the leading diagonal are not 0, but the remaining elements are 0. Next, we have the identity matrix or the unit matrix. So again, this is a square matrix where all the elements of the principal diagonal, or what we call the leading diagonal, are 1 and the rest 0. So the elements in the leading diagonal will be 1 and whatever is left will be equal to 0. So here we have 1 in the principal or leading diagonal and the remaining elements 0. The next one is equal matrices. So two matrices are said to be equal if the corresponding elements are identical and they have the same order. So two matrices are going to be equal if firstly they are of the same order and secondly the corresponding elements are identical. So look at this example. Matrix P has elements 4, 0, 6, negative 1. Matrix Q has elements 4, 0, 6, negative 1. First of all, the order of a matrix P is 2 by 2. Order of matrix Q is 2 by 2. So both matrices have the same order. Now we look at the corresponding elements. So here the first element in the first row is 4. Here also we have 4. 0 in this place in the first row, second column. Here also we have 0. Similarly, second row, first column we have 6. Second row, first column we have 6. Negative 1, negative 1. So you can see that P and Q are of the same order and the corresponding elements are identical. So we call P and Q as equal matrices. Now we are going to see how we can work with equal matrices. Find the value of the unknown in each of the following. So here you have 3 parts. We're going to see how we can find the value of the unknowns. Part A. Let us look at the order of these two matrices. Both matrices are of order 1 by 2. So these two matrices are equal. So the corresponding elements should be equal. So here A should be equal to 3. A is going to be equal to 3. Part B. The two matrices are equal. Therefore, the corresponding elements should be equal. Minus x will be equal to 5. Therefore, x equal to negative 5. Similarly, minus 3 will be equal to y. So, y equal to negative 3. The last part. Here we have 3 by 3 matrices. So, the corresponding entries will be equal. Can you try to guess for the first one? A plus 1 will be equal to? Yes, it will be equal to 7. So A will be equal to 6. Next, 5B will be equal to 15 and B equal to 3. Now, minus 2C will be equal to 6 and C equal to negative 3. D will be equal to 1. And finally, E will be equal to negative 4. Now we move on to addition and subtraction of matrices. So matrices can be added and subtracted if and only if the matrices have the same order. We can only add or subtract if the matrices have the same order. And to add or subtract, we only need to add or subtract the corresponding elements. Let us look at this example. So the first one, we need to check the order of each matrix first. So what is the order of the first matrix? What is the order here? We have a 3 by 1. Second matrix, what is the order? 3 by 1. So both matrices are of the same order. This means we can add. Now, I said earlier we need to add the corresponding elements. So here, -1 plus 3, I will have 5 plus -2 and 2 plus 4. I'm adding corresponding entries. So -1 plus 3 will give me 2. 5 plus -2 is 5 minus 2, which is 3. And 2 plus 4 is 6. Part B. First, I need to check the order. So the order of the first matrix is 1 by 2. Second matrix, 3 by 1. Do I have the same order? No. So if we do not have the same order, this means we cannot add. Therefore, addition is not possible because the two matrices are not of the same order. Part C. The order of the matrix first. So here the first one is a 2 by 2. The second one is a 2 by 2. Therefore, we can add because both matrices are of the same order. Remember, we need to add corresponding entries. So here I will add 6 plus 0, -4 plus 3, -3 plus -6, 5 plus 1. And this will give me 6, -1, -9, and 6. Part D, we check the order of the matrix first. So we have a 3 by 2 for the first matrix. Second matrix as well, 3 by 2. Both matrices have the same order. This means we can add. Again, we are going to add corresponding entries. 4 plus 0, -2 plus 9, -1 plus -3, 3 plus 6, 7 plus 2, and -2 plus -3. So adding the corresponding entries will give me 4, 7, -4, 9, 9, and -5. Now we look at an example involving subtraction of matrices. So here also we have 4 parts. Part A, again, we need to check the order first. So we have it 2 by 1, 2 by 1. Both matrices are of the same order, so we can subtract. And we need to subtract corresponding entries. So 3 minus 0, -5 minus 1. And this will give us 3, -6. Part B now. First, I need to check the order. So here you can see we have row matrix. Remember, row matrix has only one row. I have a 1 by 3, 1 by 3 for the second one. Same order, so we can subtract. 9 minus 5, -4 minus 2, and 8 minus 1. This will give us 4, -6, and 7. You will observe that when we are adding and subtracting matrices, the answer, the resulting matrix will be of the same order. So if I'm adding 2 3 by 1 matrices, my answer also will be a 3 by 1 matrix. Similarly, if I'm subtracting, let us say 2 5 by 2 matrices, the answer will also be a 5 by 2 matrix. Part C, we check the order first. We have a 1 by 2 and a 2 by 2. So here you can see we do not have the same order. Therefore, the subtraction will not be possible because the two matrices are not of the same order. For D, so here we have a 2 by 2, 2 by 2, therefore we can subtract. And again, we are going to subtract corresponding entries, just as we have done before. So we will get -2 minus 6, -4 minus 7, 0 minus 1, and 1 minus -3, which will give us -8, -11, -1, and 4. So you now have some exercises to practice on what we have just learned together, that is order of matrices and addition and subtraction of matrices, as well as what we call equal matrices. So first question is on order of matrices. Second question, which of the following matrices are equal? Number 3, find the value of the unknowns, where we have the equal matrices. Number 4, you need to evaluate where possible. So remember, you have to check the order first. And you have 2 interesting links where you can get additional practice on what has just been explained to you. So students, in today's lesson, we have learned how to display information in the form of a matrix and how to add and subtract matrices. I hope you have understood the different concepts. Until we meet again in the second part of the chapter, it's goodbye from me.